Hi everyone, I want to welcome you back to another session of BMT review on GCSE past question papers. We'll be dealing today with chemistry. We'll be looking at atom and its structures. So if you have been following our videos, we were taking some topics, and then today we are going to be talking on an atom and its structures. So go on with us. If you are just joining this video for the first time, just look below and then just strike that button and subscribe as you go on with us. So we'll be looking at atom. What is an atom? An atom is the smallest part of an element that can exist on its own. An atom, some definitions, some textbook define it as the smallest indivisible particle of an element that can have separate existence. So there are several definitions, but the most important thing is that it is the smallest part of an element that can exist. Now we said it is the smallest part of an element. What then is an element? An element is a substance of only one type of atom. A substance of only one type of atom is called an element. So where question may come in GCSE, how are the elements listed and X approximately how many are they? So the elements, how are they listed? Now elements are listed in the periodic table. Now there are approximately 100 of them. So if you look at the periodic table, you look at the rows, you look at the column, group 1 element, group 2 element, group 7 element, group 8 element, and then the periods. And as we advance further, we're going to be looking at how this periodic table works and how these elements are arranged and how we can determine what are the characteristics of elements in the same group, in the same period, or whatever. So elements can be classified into two groups based on their properties. What are these groups? Now, elements are classified based on their properties. We have the metals, we have the non-metals. We have metals and we have non-metals. So in between them are some of the elements that exhibit both the characteristics of metals and non-metals. So they are semi in between, but the major elements are in the periodic table are metals and non-metals. So elements may combine through chemical reaction to form new products. What are these new substances called? This may be another question. This may be another way that GCSE may arrange them. So what are these substances called? They are called compound. So compound in other words can be defined as the combination of elements to form new products. The chemical reaction of many elements to form new products. And these products are called compound. So compound is formed when two or more elements react chemically. So these are called compound. And then in the formation of compound, new substances are formed. And the characteristics of these new substances are different from the individual elements that are involved in it. So let's take note of that. What are compounds then now? Compounds are two or more elements, as I said earlier, chemically combined in a fixed proportion, which can be represented by a formula. Now, example of compounds are hydrochloric acid, when hydrogen react with chlorine, they form hydrochloric acid. When water react with when hydrogen react with oxygen, it form the resultant effect is compound is water, which is H2O, combination of hydrogen and oxygen. So water is the new substance that is formed. It is that compound that is formed, which is water. Now, the water has an entirely different characteristic from the individual element, which are hydrogen and oxygen that combine to form the water. So, do compounds have the same properties as their constituent element? As I said earlier, compound will not have the same. No, the answer is no. Compound don't have the same properties as their constituent element because a new substance entirely is formed. For instance, when hydrogen reacts with oxygen, hydrogen is an element that has its own properties. Oxygen is an element that has its own properties, but when they chemically combine together, when a chemical reaction takes place between hydrogen and oxygen, a new substances, an entirely new substances are formed that comes with its own properties. That is water. Water comes up with a different property, different from that of hydrogen and oxygen. So the answer is that compounds have no same properties as their constituent element. So that is it. What is a mixture? Does it have the same chemical properties as the constituent element? Now we look at compound, we say compound is a combination of two or more elements chemically combined. Now what are mixtures? A mixture consists of two or more elements or compound not chemically combined together. Now that gives us the differences between compound and mixtures. Compound are chemically combined, and then while mixtures are not chemically combined. It further says that it does have the same chemical properties. Why? Because they are not chemically combined. So mixtures are just temporal. They can be reversed. While in terms of compound, it cannot be reversed. A new substance is formed. For instance, when hydrogen reacts with oxygen, it produces water. That is a compound, a new compound that is formed from the chemical reaction between hydrogen and oxygen. But in case of a mixture, in terms of mixture, the mixtures have the same properties as their constituent element. They do have the same chemical properties as their constituent element because they are temporary. The example of mixtures are when salt dissolves in water. When salt dissolves in water, that is a mixture. A salt solution is formed, and then this salt can still be separated, and then the water can still be separated. Water there still has its own property. The property of water still remain. The property of salt still remain. They are just mixtures. They are temporal components that still retain their individual properties, unlike compounds that have different properties from their constituent element. So what are the methods through which mixtures can be separated? Now, we said mixtures are easily separated. You can see they come temporarily and then you can separate them. So example is when you pour granite into water. Granite is an insoluble solid. Then water is there. When you pour it, the mixture of water and granite can easily be separated because you can use sieve as well. Pour it to a sieve and whatever. So we are going to be looking at technically some of the separation techniques, which are filtration, crystallization, simple distillation, fractional distillation, chromatography, and several others. We have sublimation and others. So we are going to be looking at some of these. So these are 5. We asked to list 5. So when you're asked to list more, there are more. We have distillation. We have fractional distillation is there. Chromatography is here. Sublimation is also there, and others. So these are examples of ways by which mixtures can be separated. Describe and explain simple distillation. Now, simple distillation is used to separate liquids from a solution. The liquid boils off and condenses in the condenser. The thermometer will reach the boiling point of the pure liquid, contrary to evaporation. We get to keep the liquids. Now, the difference between simple distillation and evaporation is that when you are trying to separate salt, a mixture of salt from water, salt is already a solution. Now you can separate that salt back, you can retain that salt back, and still retain the water back. When you boil the water, water boils at 100 degrees Celsius. Once it reaches that temperature, then water evaporates. It begins to evaporate. But we still need the water back. So there is an instrument that we place which is called the condenser. The condenser is placed as to trap these water vapors and then reverse them back. When it gets cold, it gets back to its liquid stage as water. Then as the water evaporates, it is trapped by a condenser, and then it revolves back to water, leaving the salt in the boiling container or in the boiling container. So that is how it's separated. So a simple distillation is separation of liquid from a solution. Now liquid may be water, a solution may be a salt solution. So you can separate water from a salt solution, you still get your salt back, and you still get your water by what? Simple distillation. While in evaporation, we don't need the water. We are just after the solid. So evaporation, I can say, is the way of recovering the solid from a solution. We are not concerned about the liquid. Let the liquid go. Now, in this case, you don't need a condenser. You boil the water, and then the water reaches its boiling point. It evaporates, leaving the solids there. So as soon as the water evaporates completely, it leaves the solids there. So that is what we call evaporation. So that's the difference between simple distillation and evaporation. Describe and explain crystallization or an evaporation. So this is I've explained evaporation already. We're going to be describing this crystallization. I say evaporation is techniques for separation of solid dissolved in a solution from solvent. Now, the example is salt from water. We want to recover the salt. You are not interested in the water, let the water go. You don't need condenser. But in case of distillation, you need a condenser to recover the water back. Both constituents are retained. The solution is heated until all the solvent evaporate. The solid stays in a vessel. Now, this is how I said. Now, we are going to be working with board. I'm going to share the screen and then show us how this this is obtainable, how we can obtain this practice. Now we have our boiling pan here containing our solution of water and the water and the salt solution is here, and then you introduce heat here. We introduce heat. When we introduce heat and it boils, in terms of evaporation, you don't need evaporation. The water boils at 100 degrees Celsius. As soon as it reaches, it evaporates, leaving the salt content. So only the salt will be left under the container. That is what we call evaporation. So in evaporation, this goes away. But in condensation, in simple distillation, you need a condenser. You need a condenser. As the water evaporates, there is a condenser that traps the water back. It goes in here, and then the water is retained, and then the salt itself is also retained. So this is what we call simple distillation. Simple distillation. Simple distillation. So in simple distillation, we have this, we need both constituents. The water recondenses back to its water, the vapor recondenses back to water, leaving the salt here. So the solution of salt remains here, and the water goes back. In evaporation, we don't need the water, so we just need the salt. It remains under here. So that is just that. So that is a typical of how the difference between evaporation is. Now in crystallization, it is similar, but we only remove some of the solvent by evaporation to form a saturated solution. The one where no more solid can be dissolved, then we cool down the solutions. as we do it, the solid state starts to crystallize as it becomes less soluble at low temperature. The crystals can be collected and separated from the solvent via filtration. Now, in this case, evaporation is involved, and then a boiling state is involved. When it boils to reach a particular stage that it is allowed to cool, then then a filtration is applied so that we can recover this. So that is how crystallization works. So that is how crystallization works. Now describe and explain fractional distillation. Now fractional distillation, there's simple distillation, there's fractional distillation. Fractional distillation is a technique for separation of mixtures of liquid. It works when liquid have different boiling point. Now it works where you have liquid of different boiling point mixed together. If you want to separate them, then you apply fractional distillation. The apparatus is similar to one of a simple distillation apparatus with the additional fractioning column placed on top of the heat flask. The fractioning column is there to collect the different liquids at different stages, and then it keeps them separately. For instance, that is the principle that is applicable in the extraction of crude oil, how crude oil, petroleum is separated from kerosene, from gasoline and whatever. So at different boiling point, the first one that has a closer boiling point goes up, the subsequent one goes up until it goes, and then they move into different chambers, and that is how you separate them. So fractional distillation is a process of separating, is a technique of separating mixtures of liquid of different boiling point, liquid that have different boiling point. Now describe and explain filtration. Now in filtration, we have the apparatus called the filter paper and then the funnel. Now in filtration, we involve a separation of insoluble solid from liquid. Now, liquid that cannot dissolve, for example, groundnut and water, you can use filtration to separate them, or anything that cannot dissolve in water, any solid that cannot dissolve, you can use filtration. Now, you can use the filter paper, you pour the solution of both inside the filter, then we have the filtrate. The filtrate passes while the residue remains on top of the filter. So that is how it works. So that is actually how it works. So I'm going to end by showing us a description of how filtration takes place, and then we are going to end with that. Now, by the time we come in next time, we're going to continue with that. So in filtration, this is what happens. This is the filter. Let's assume this is our filter paper. The filter paper is here. Our solution is poured in here. The solution of the insoluble liquid from this thing is poured into the filter paper. As it is poured, the liquid passes under as filtered. Then a container is kept here to trap those liquid. Now the liquid passes under, and then those ones that pass under, we call them filtrate. The filtrate is passed under, passes through the sieve or through the filter, leaving the residue here. Now the residue is now the insoluble. This is the residue. So this is how the filtration process takes place. In the filtration process, we have the filter, and then we have the filtrate, and then we have the residue. The residue remains trapped on the filter paper, and the filtrate passes under. That is how you separate. Two immiscible liquid from solid. So I hope you enjoyed today's class. Do subscribe next week for more videos, as more videos will be coming. This is a series on GCSE. We deal with chemistry, physics, and mathematics. Today we're dealing with physics, and we're able to look at, in a recap, we're able to look at atom, and then we're able to look at how atom exists. We're able to look at the definition of element, the difference between mixture and compound. We're able to look at, I would say, mixtures are temporary, they can be separated. So we have to look at separation techniques like filtration, simple distillation, fractional distillation, chromatography, and then crystallization and sublimation, whatever. I say that when you want to separate different techniques are involved. So by next week, we're going to be continuing this session and looking at other ways of separating mixtures, and then we're going to look at more complex ways, other complex topics attached to the atomic nature. So thank you for watching, and bye bye for now.